Hi there, today I want to talk about one of these high voltage modules. I've seen them by myself in many other videos. They are obviously sold on many Chinese shops on the websites. They are advertised as paralyzer with 400 kilovolts. And at least at the half of the videos that I've seen about these modules, the user destroyed them because they say pretty much do not get these wires too far away, do not let it run for a few minutes or something like that. And most people, of course, do get the wires further and further away because they want to see how far the spark clip goes, and then suddenly it breaks and is destroyed. And I want to talk about this module a little bit and want to get in detail why it gets destroyed with a poor drawing, but I attempt to explain it to you. And also I'm doing some questions. First of all, I'm going to explain you stuff. So here is a schematic. This is not the schematic of the module. I haven't been able to open one of these, at least I haven't even attempted. But if you look at this, don't even try. Okay, so this is how I would make it if I was supposed to make such a module. I would build a simple Joule thief, and you can see this Joule thief circuit is very simple. It has a 3-turn primary coil and a 10-turn feedback coil, and of course like 5,000 turns. I'm just guessing. 5,000 turns or so of a secondary coil. And then you have a diode with like 25 kilovolts. I've seen these around. I even have one here. I think it's 25 kilovolts, but I forgot to get it out to show it to you. It's like this long. So this long, and it's this thick. So this is like a 25 kilovolts diode. And then you have a capacitor somewhere in the 1 nanofarad 25 kilovolts range. And then of course you have your high voltage output leads. And what most people are doing, because they are curious, is get these leads too far away. And by doing some experiments with this module, as I say, this is just guessing, there seems to be a capacitor inside. Obviously a foil capacitor. Or it could be a ceramic too, but I guess it's a foil capacitor. And here is a very poor drawing, an attempt to show you a foil capacitor. So imagine the black and the red being tin foil. You know tin foil. It's not exactly tin foil, but for your imagination, the black and the red is tin foil. And the yellow one is a normal foil. Like a foil where, for example, this wire would be packed in if you buy a new camera. Or the foil where you can put a bread in for breakfast. So just a normal foil. And what they do is they make one layer, as if I would wrap one layer tin foil around this. Then they add one layer of the normal foil above the tin foil, and then they add another layer of tin foil. So you have tin foil, foil, tin foil. And one contact goes to one side of the tin foil, then there is the isolating foil, and the other contact goes to the other side from the tin foil, and that forms a capacitor. Of course, they are not using one layer, they are using a couple of layers and wrap them around each other to increase the capacitance. But this is pretty much how a capacitor works. Now what happens if you do these wires too far away? The voltage between these two connections, between these two tin foils, will get so high that this normal foil can withstand the high voltage, and it will pop somewhere. Somewhere will be a hole punched through. The high voltage will eat itself through the foil, and then it will punch a hole inside. And it could be like this hole has a distance of 0.1 millimeter. That means that inside the device there is always a spark arcing, and you would eventually get out 100 volts or so. Instead of 25,000 or 20,000, you would only get out 100 volts. And it even could get worse, that these two foils touch, and then you would get out 0 volts because it's internally short-circuited. That's the reason why it pops if you do these wires too far away. The next thing is, they say don't power it like on 6 volts for too long. That's because this thing, I've done some experiments with it, has really impressive power output. And to make this power output, it draws a couple of amps even. You need to have some power transistor, and this power transistor in this thing obviously gets hot. And if we let it run too long, it will get so hot the transistor will get destroyed. And this is pretty much why this thing is limited a little bit. But it's not completely limited. You can work with it for many minutes, if you want to call it like that, and also with the wires put that far away. So I'll demonstrate that to you. So as if I were connected now to my 6 volt battery, 1 second and it's popped. But I connected. So I have connected it. And it's just healthy and working fine. I could let it run like 1 minute, which I don't want to do because I don't want to waste the video time. But as you can see, it's just healthy and fine. And what have I done? Instead of connecting it, they suggest here I think something in the range of 2.4 to 6 volt supply voltage. But I've connected it only to one battery, which is only 1.2 volts. And additionally, I'm using a long wire between the connections. This wire will drop the voltage a little bit. And so I'm running it like 1.1 volts supply voltage. I'm running it below the specs that they give you. And so the output voltage is so low that if I would run it for an hour or so, never this capacitor will go to pop. But if I will connect it, I will show you that. So I will make a spark gap which is like 1 centimeter. They say, okay, you can put the wires, I think it was somewhere in the range of 1 to 1.5 centimeters. You can put them that far away. So this is now 1 centimeter. If I connect it to my 1.2 volt battery, nothing happens. Of course you can't hear it on camera, but I can hear the inverter inside working. And now I'm doubling the voltage to 2.4 volts. And you can see there are some sparks, which are also very loud, which tells me this thing has really much power. I don't want to destroy this thing, I only have this one. I don't want to destroy my only power inverter. I will put them a little bit closer together. This is like 0.8 centimeters or 8 millimeters. Now I go 2.4 volts and 3.6 volts. So this is 2.4, this is 3.6. So this is so strong. It's just, this is my next question. What's the purpose of this thing? I was really sitting there looking at it and asking me what's the purpose of this thing. I mean, yeah, they sell it as taser, as defensive weapon, but you can't connect this to your human. I mean, it would give you serious burns on your skin, and I don't even want to know how this hurts. This is way too strong. And the other thing is, I could imagine there are these testers. If you are an electrician, you know this. If you make an installation of wires in a house, you have to test the isolation because the wires shouldn't short and you should have done everything right. And there are these testers, they put 1 kilovolt on these wires, and then they say, okay, it has like more than 100 mega ohms of resistance, it's fine. And I could imagine they use one of these and power it with like 0.5 volts, and then will make like 1 kilovolt, 2 kilovolt, and they use these in these testers. This is one thing that I could imagine where this thing is used. And if and the Chinese found out, okay, you can sell it as electric shocker or something like that, and if you go like 3.6 volts, it will get insane voltages on the output. Another thing is on a photocopier. You know, you have to ionize the paper so that the color stuff holds on the paper. So this could be used in a photocopier to generate like 5 kilovolt. It puts out 5 kilovolts, no problem whatsoever. And then you can use it on a photocopier. This is another thing where I could imagine they could use it. But I've seen this around quite often lately. On many pages, they even like on the first page advertised. And I'm just curious where they were used for, or what's the original use of these things. I just can't. It's like a fun project where I can make some sparks. I mean, I will show you in this video, I will show you some applications that I can use it for. But I'm just curious. You can write it in the comments what you think, where this thing is used for. I can't imagine they just produce it for electrifying people, because once again this output is, you just can't touch it. This is really dangerous. And the other thing is, back in the 80s there were already these tasers. So yeah. Okay, one thing I will show you is wherefore you can use it if you are a hobbyist electrician and so far and so on. Of course you are doing all this high voltage stuff in your own risk. So here we are back again. I have now connected this. So this transformer that you see here is a so-called flyback transformer. This one is a very old one that puts out AC. And in CRT televisions these things were used to generate the high voltage for the picture tube. Anyway, what I've done, I've connected the output from my high voltage generator. I've shifted it a little bit. So I've connected the output to one pin from the input from this transformer, and the other pin from my high voltage device has been placed close to one of these pins. So there is an arcing over. So you can see it. They're connected. Well, this could be a little bit better. So you can see there is a small spark. This is 1 millimeter, 1 or 2 millimeters long spark. Nothing special, quite tiny. But now if I take my wire and hold it to the output, I can get much stronger sparks. So I connected, this is 1.2 volts input, 1.2 volts input. And now let's look. So you can see it. So this is one way or one thing that you can do with this high voltage device. At least one thing that I can do. Now you are asking, why don't you make the spark longer and connect it to 3.6 volts? Then you would get like sparks of this length. Not kidding. But no, I just don't. I don't want to destroy this transformer and I don't want to destroy this device. Why do I know that I get these long sparks? When I was young, I was also using similar experiments. I was using a xenon flash tube with a photo flash capacitor, which got discharged into a similar transformer than this. Not kidding, I got sparks of this length. So you can see here is one electrode and here is the other electrode, and this worked like 10 seconds and then the transformer was bad. But so yeah, this is just one explanation of one thing that you can do with it. You can mess around with it, you can play around with it with this Chinese high voltage module. Okay. So now I've connected my high voltage module to my Tesla coil. Here in the green connection you can see a spark gap. I just placed the wire at some distance from the other wire, and so it makes a spark gap. Here I've made a primary coil. I'm using 4 meter long wire, 12 feet long wire, just rounded around this plastic tube. The other side from this secondary coil is grounded to a water pipe. And here's my streamer / spark gap output. So here are the sparks. I'm connecting it to 2 batteries, not 3, just 2, and these batteries aren't the freshest. They aren't really that charged anymore. They are a little bit charged, a little bit charges left, but not completely full. So I'm just using 2 of these for supplying my high voltage module. I connect it, and you can see the spark gap is working. Now you can see streamers, but you can't see them good on camera. You can see them a little bit, but now I'll help you. So you can see streamers. If it would focus, it would be better. So you can see these streamers. So now I'll take an energy saver bulb, and if I get it close, you can see it lights up, as does the neon bulb and the screwdriver. Now if I get the ground connection close to the output, see what happens. Well, if it would focus. So this is another attempt. Maybe the electronic was confused by the high voltage. Now I got it kind of focused, and here we can see sparks on the output. The Tesla coil is not perfectly tuned. So this is 1 inch. Not bad, not bad.